Good day girls and welcome back to the class. Today we'll do Science and Technology 1. The chapter we'll be doing today is Refraction of Light. We'll do this chapter in two parts. Today we begin with the first part. Okay. The topics to be covered in this chapters are refraction of light, laws of refraction, refractive index and dispersion of light. Now, before we go to study what is refraction of light, let us just recall what did we learn about reflection of light. You know something, you have learned something about reflection of light. Can you just recall and try to understand what is meant by reflection of light? Well, I can say that when rays of light falls on a smooth surface, they turn back. This is called as reflection of light. You must have definitely even studied what are the laws of reflection. Now let us recall them again. There are three laws of reflection. The first one, the incident ray, the reflected ray and the normal are all in the same plane. The second law, the incident ray and the reflected ray are on opposite sides of the normal. And the third law of reflection is the angle of incidence and the angle of reflections are of equal measures. So by just recollecting this laws of reflection, I'm sure you must have recollected these terms and understood what is incident ray, what do you mean by reflected ray, what is a normal, what is the angle of incidence and the angle of refraction. Okay, so we'll be using these similar terms even when we are describing about what is refraction. Okay, so to understand, okay, now before we go to again refraction, one more thing I would like to say, that you must have learned that light travels in a straight line. Okay, and because of this we can say that when an opaque object comes in its path, a shadow of that object is formed. We have also seen in the previous class that these shadows change due to the change in the relative position of the source of light and the object. Okay, so this is what you have been learned, that light travels in a straight line. A shadow is formed when an opaque object comes in the path. You must have learned the definition of reflection, the laws of reflection, the types of reflection and so on. But in this chapter, refraction of light, we are going to study that light can bend. It is not necessary that the light travels in a straight line. Light can bend, but under some special circumstance. So we are going to study that part today, that what happens when the light bends under some special circumstance. So before we go to study in detail about the refraction of light, let us watch a small video. Take a transparent glass and fill it with water. Dip some portion of a pencil vertically in water and observe the thickness of the portion of the pencil in water. What do you observe? We observe that the portion of the pencil inside water appears to be thicker than the portion above water. Now, keep the pencil inclined to water surface and observe its thickness. In this case, we see that the pencil appears to be broken near the surface of water. Can you guess why does it happen? Okay, in this activity, the observed effects are created due to change in the direction of light while coming out of water. Okay, so we can say that light changes its direction while going from one transparent medium to another transparent medium. This is called the refraction of light. Okay, so let us study now refraction of light. Now let us have a glass slab PQRS. Okay, PQRS is a glass slab. Okay, now here let us consider the incident ray AN. Now you have learnt reflection of light, correct? Now here we are going to study refraction of light. Now AN is the incident ray. Okay, so here the first refraction occurs. The first refraction occurs when the light ray enters the glass from air at N on the side PQ. Okay, so here we have air and we have this glass. Okay, so there are two different medium. This is air and this is glass, but both are transparent medium. So here the light ray is entering from one transparent medium, that is air, to another transparent medium, that is glass. And when the ray of light moves out, then we can say it is moving from glass to air. So we are going to trace the path of light when it travels from one transparent medium to another transparent medium. I repeat, in this diagram or in this figure, we are going to trace the path of light when it moves from one transparent medium to another transparent medium. So we have the first transparent medium here, air, AN. So this AN is the angle of incidence. It is the incident ray. This incident ray makes an angle with the normal. This angle is known as the angle of incidence. Remember, this incident ray makes an angle I with the normal. You can see another angle formed over here, ANP. That is not the angle of incidence. This is where I is written as the angle of incidence. Okay. Then if we say that light travels in a straight line, it should have gone like this following the dotted path. But that does not happen. Instead, you can say at N, the ray bends. This red ray, what you see is the bending of the light ray. So you see here, this is the normal. This ray of light bends towards the normal. So the bending of light rays takes place when it is going from one transparent medium to the other transparent medium. Here you can say, since it is bending towards the normal, we can say that the angle of refraction, R, this is the angle of refraction, is smaller compared to the angle of incidence. Okay, so the air is traveled from air to the glass medium. Okay, now we can say, now the air is moving through the glass medium, and now here the second refraction takes place at M on the surface SR. So again, now it is moving from one transparent medium to the other transparent medium, that is from glass to air. So the second refraction is taking. Now if you look at this figure over here, this ray, and here it is again there, it is bending. The ray of light is not moving like this, but it is bending. This time it is bending away from the normal. This angle here is called as the angle of emergent. Here I1 is the angle of incident, and here the ray coming out from the glass medium, this angle is known as the angle of emergence. The ray is emerging out. The ray of light is emerging out. Okay. Now here we go to see here, this part to this part over here, it is taking place in the same medium. So we can say that this angle R is equal to angle I. Now this angle I is smaller than the emergent angle of emergence, because it is moving away from the normal. Okay. Now if you look at this ray AN and if you look at this ray MD, they are parallel to each other. And I want to say one more thing here is angle I, that is the angle of incident here, is equal to the angle of emergent. That means angle I is equal to angle E. Okay, but here you must observe from the figure, you can say that the emergent ray, this emergent ray MD, is somewhat displaced with respect to the incident ray AN. So this gives us the path of light, okay, traveled from air to glass, from glass to air. So here we can say that because air is moving from one transparent medium to another transparent medium, there is bending of the ray of light. Okay, this process is known as refraction of light. Now let me ask you a question over here. Will light travel through a glass slab with the same velocity as it travels in air? Now here, so far we were discussing about the direction of the ray of light. Now we are talking about the velocity. Will the velocity of the air of the light be the same in air and medium? That is what the question means. Will light travel through a glass slab with the same velocity as it travels in air? Well, the refractive index depends upon the velocity of light. We'll be doing what is refractive index. Okay, as refractive index increases, velocity of light decreases. Since refractive index of glass is greater than air, the velocity of light in glass is less than that in air. That means the denser objects will have greater refractive index and therefore the velocity of light will be less. So the velocity of light will be more in air and less in glass. Again, another question I would like to ask. Will the velocity of light be same in all medium? Again, the answer is no. Okay, because refractive index depends upon the velocity of light. Refractive index is different for different media. Velocity of light will also be different for different media. Okay, now let us go and study the laws of refraction. We revised what is laws of reflection. Now we will study the laws of refraction. Now here, observe the figure. Okay. Okay, we'll study the laws of refraction. The incident ray and the refracted ray at the point of incidence N are opposite side of the normal to the surface of the slab at that point. That is the ray CD. Okay, and the three incident ray, refracted ray and the normal are on the same plane. That is the incident ray AN, the refracted ray NB and the normal CD are on the same plane. Second, again I will repeat. The first one is the incident ray and the refracted ray at the point of incidence are on the opposite side of the normal. That is the incident ray and the refracted ray are on the opposite. That means one is on the left side, one is on the other side. Then the incident ray, the refracted ray and the normal are on the same plane. The second one is for a given pair of media here, that is air, one medium and the other medium is glass, the ratio of sin I to sin R is constant. Here I is the angle of incident and R is the angle of refraction. Okay. Now here this is angle of incident and angle of refraction. This will never be the same. I will never be equal to R because it is moving from one medium to another medium. Your air is considered to be a rarer medium and glass is considered to be a denser medium. Okay, so this refracted ray will always bend towards the normal. So R will always be less than I. Okay, but for any ratio of SI upon SR, that is the ratio of sin I to sin R, whichever value of I you get the value of R, the ratio will always be constant. Okay, so let us try to look what is there in this box. Sin I upon sin R is always a constant which is called mu. Now this is called as the refractive index of the second medium with respect to the first medium. This second law is also called as the Snell's law. That is the second law of the reflection. The second laws of refraction is also called as the Snell's law. A ray incident along the normal, that is when I is equal to 0, goes forward in the same direction as R is equal to 0. We will be doing this part in the last part of this chapter. Okay. Now the refractive index. What do you understand by refractive index? The change in the direction of a light ray while entering different media is different. Okay, that we have already seen now, that there is a change in the direction of the path of light. It is related to the refractive index of the medium. The value of the refractive index is different for different medium and also for light of different colors for the same medium. Now what do you understand by that? See, first of all, the refractive index is different for different medium. Okay, and second thing is the refractive index is also different even if the light ray is traveling in the same medium. But here what it means is the light is made up of different colors. Okay, so if a light is moving in the same medium, maybe in the glass or air, but the different colors in that white light will have different medium. The refractive indices of some substance with respect to the vacuum is given in the table in textbook page 75. Now the refractive index of a medium with respect to vacuum is called its absolute refractive index. Okay, now here you have the table. Okay, this table is given in 3 rows, but only this part is there for the exam. The remaining 2 column is deleted. So girls, you can just go through the value of refractive index, okay, of these air, ice, water, alcohol and kerosene. Okay, now let us study refractive index. Now let us look into the figure. We have 2 medium here, medium 1 and medium 2. Medium 1 is air and medium 2 is glass. Now let us talk about, so far we were talking about the direction of the ray of light. Okay, now we are going to learn little about refractive index and velocity. Okay, let the velocity of light in medium 1 be v1. Okay, this is medium 1 and velocity be v1, and in medium 2 let the velocity of light be v2. Okay, now the refractive index of the second medium with respect to the first medium. Here the refractive index, it is always written like that, from the second medium with respect to the first is given to be velocity of light in medium 1, that is v1, upon velocity of light in medium 2 is v2. That means the refractive index, again I repeat, the refractive index of the second medium with respect to the first one is v1 upon v2. Similarly, the refractive index of medium 1 with respect to medium 2, that is here mu. Okay, refractive index of medium 1 with respect to 2 is given to be v2 upon v1. So here we are talking about refractive index with respect to the velocity of light. Okay, this is just, I have already explained this when I was talking about refraction of light. Okay, refraction of light in the different media. Okay, so here we have a glass slab. Okay, air is moving from a rarer medium to a denser medium. Always remember, glass is always more denser than the rarer medium. So the blue one is the is the incident ray. So when the incident ray moves from a rarer medium to a denser medium, it moves towards the normal. Okay, so here we have angle I greater than angle R. Okay, here now the light ray has to move from the denser medium to outside the glass slab, that is the rarer medium. Okay, yeah. So it is moving from denser medium to the rarer medium. You can see that the refracted ray moves away from the normal. So here angle R is greater than angle I. Now here in this figure you can see there is a glass slab over here. When the light ray is incident, normally at the boundary between the two, it does not change its direction and hence it does not get refracted. Remember, when we were doing Snell's law, it was written when angle I is equal to 0, angle R will also be equal to 0. That means if the incident ray is at the boundary between the two media, angle R will be 0, therefore angle I will be 0, therefore angle R will also be 0, and hence here in this case the incident ray will pass straight and it does not get bent. So in today's video we will stop till here. In the next video, we will be we will be learning the different effects, or we could say the different application, okay, on refraction of light. Thank you and have a good day.